Enthalpy of reaction. Enthalpy, it is simply the amount of heat absorbed or released by the reaction. All reactions have some amount of enthalpy. Combustion reactions obviously release large amounts of heat. They have a negative enthalpy. A negative enthalpy represents an exothermic reaction which releases heat. A reaction that absorbs heat is endothermic. Its enthalpy will be positive, and it will cool down its surroundings. Exothermic. For the notes, you will need to write down this equation. 3 carbon plus 4 hydrogen yields C3H8, and this reaction has a delta H of minus 104.67 kilojoules per mole. This reaction is exothermic. This reaction is exothermic. Negative enthalpy means that it releases heat. When the reaction occurs, the surroundings will increase in temperature due to the gain of heat the system releases. For every mole of propane formed, 104.67 kilojoules of energy are released. Endothermic. For the notes, you will need to write down this equation. N2 plus O2 yields 2 moles of NO2. The delta H is positive 756.05 kilojoules per mole. This reaction is endothermic. Positive enthalpy, absorption of heat. When the reaction occurs, the surroundings will decrease in temperature due to the loss of heat the system absorbs. For every mole of NO formed, 378.3 kilojoules of heat are absorbed. Note that the reaction shows 2 moles being formed, so the enthalpy is double that of 1 mole being formed. Calorimetry. Calorimetry is the quantitative measurement of the heat required or evolved during a chemical process. A calorimeter is an instrument for measuring the heat of a reaction during a well-defined process. Here is an example of a calorimeter. We have a burner of some sort. You could put a peanut or popcorn or some kind of substance that you want to burn here, and this would be the amount of water that you're going to try to heat up. This is the thermometer to measure the heat change in the water. This container is usually insulated at the top so that we don't lose any heat to the environment. calorimetry. Equation that is needed to be known. Q equals mc delta T. Q equals energy transfer in joules. M is the mass of water in grams. C is the specific heat capacity. And delta T equals temperature change in either Kelvin or degrees Celsius. Q equals mc delta T, which is the same as the picture. Q is enthalpy, or the change in heat, or the delta H. M is the mass of the water. C is the specific heat of the water. Delta T is change in temperature, where you have T final minus T initial. That will give you the change in the temperature.